Welcome viewers to today's lesson on Archimedes principle, a continuation of Teacher Mercy's lesson, specifically tackling on numerical problems on Archimedes principle. We want to look at a question concerning the Archimedes principle.
The figure below shows a wooden block of dimensions 60 cm by 40 cm by 30 cm held in a position by a string attached to the bottom of a swimming pool. The density of water is 1000 kilograms per cubic meter. So question Roman 1, calculate the pressure at the bottom surface of the block. That will be 3 marks.
Calculate the pressure at the bottom surface of the block. Now we know that pressure in liquids is given by density times the acceleration due to gravity times the depth. Now the density of the liquid, in this case is water, has been given as 1000 kilograms per cubic meters, and acceleration due to gravity is 10. So we need to find the depth of the water up to the bottom surface of the block. From the surface of the water, it is 40 centimeters up to the top surface of the block, then 60 centimeters up to the bottom of the surface of the block. Therefore, the depth up to point Q of the water is 100 cubic centimeters, which we convert into meters by dividing by 100. So that gives us 1 meter. So when we multiply this one, it gives us 10,000 newtons per square meter, or 10,000 pascals. That is the pressure at point Q, the bottom surface of the block.
Then Roman 2 is draw graph to show how the pressure on the block changes between P and Q. I believe you can see P and Q there.
Draw a graph of pressure changes between points P and Q. So from the pressure concept in Form 1, we understand that the pressure in liquids increases with increase in depth, implying that pressure at point P is lower than pressure at point Q. So if we have to represent it on the graph, then it will be as follows. So this is pressure on the y-axis in newtons per square meter. Then this is point P, and we also get point Q. So point P is experiencing some pressure, so we don't begin from 0, and this pressure is lower than pressure at point Q. So pressure at point Q is higher, and pressure increases from point P to point Q.
Roman 3 is determine the upthrust on the block by water. It's also 3 marks.
Determine the upthrust or upthrust on the block by the water. There are two approaches that we can be able to have. One is to apply the Archimedes principle, and the second one is to apply the pressure differences on the surface P and surface Q of the block. So we shall begin with the first option of Archimedes principle. Now Archimedes principle says that when a body is partially or fully immersed in a fluid, it experiences upthrust, which is equal to the weight of the fluid displaced. So in this case, we need to get the volume of water displaced. Volume of water displaced which is equal to 30 centimeters by 40 centimeters by 60 centimeters, which gives us 72,000 cubic centimeters. Then from the volume of water displaced, we get the mass of water displaced. Which is given by density of the water times the volume. And the density of water in grams per cubic centimeters is 1 times the volume, which is 72,000 cubic centimeters, so that we get the answer in grams. And this one gives us 72,000 grams, which is equal to how many kilograms? We divide by 1,000 to give us 72 kilograms. Then after getting the weight, the mass of the water displaced, we get the weight of the water displaced. Weight of water displaced. And weight is given by mg, mass times the acceleration due to gravity. In this case, it's going to be 72 times 10 to give us 720 newtons. Now, according to Archimedes, this weight of water displaced is equal to upthrust. So we imply that weight of water displaced is equal to upthrust. And for us, the question is asking for the upthrust, so that means upthrust is equal to 700 and which is given by density of the water times the volume. And the density of water in grams per cubic centimeters is 1 times the volume, which is 72,000 cubic centimeters, so that we get the answer in grams. And this one gives us 72,000 grams, which is equal to how many kilograms? We divide by 1,000 to give us 72 kilograms. Then after getting the weight, the mass of the water displaced, we get the weight of the water displaced. Weight of water displaced. And weight is given by mg, mass times the acceleration due to gravity. In this case, it's going to be 72 times 10 to give us 720 newtons. Now, according to Archimedes, this weight of water displaced is equal to upthrust. So we imply that weight of water displaced is equal to upthrust. And for us, the question is asking for the upthrust, so that means upthrust is equal to 720 newtons. And that's the solution to that question. That's the alternative one. Maybe just a brief overview of the sum. We get the volume of water displaced, which is given by the length times width times height of the block, to give us 72,000 cubic centimeters. Then this volume of water displaced, we can be able to find its mass by getting the density of water times the volume of the water displaced to give us 72,000 grams, which is equal to 72 kilograms. Then after getting the mass, we get the weight of the water displaced, which is given by mg. So that is 72 kilograms times 10 to give us 720 newtons, which according to Archimedes, this weight of the water displaced is equal to upthrust. Therefore, we have responded to the question as required. Alternative 2, we use the concept of the pressure difference between points P and Q. So we begin by calculating the pressure at point Q. So pressure at point Q is given by rho GH, the density of the water is 1000 kilograms per cubic meters, G is 10, and the height, which is the depth, is 40 centimeters plus 60 centimeters, which gives us 100 centimeters, equivalent to 1 meter. So this gives us a pressure of 10,000 pascals. So we need to determine the force on surface Q exerted by the water. So how do we get that force? We say pressure is equal to force over area. Therefore, force is equal to pressure times area. So in this case, the pressure is 10,000, then times the area of the base bottom surface, which is 30 centimeters by 40 centimeters. So that gives us, in meters, is 0.3 by 0.4, 0.3 by 0.4, and this gives us 1,200 newtons. So a force of 1,200 newtons will be experienced on surface Q. So we also need to get the pressure at the top of the top surface of the block. That's pressure at point P, is also given by rho GH. The density of the water is 1000, G is 10, and the depth is 0.4 meters. And this gives us 4,000, a pressure of 4,000 pascals. So we also need to get the force exerted on the top surface P by the water. So we also get that force is given by pressure times the area. Pressure times the area. And the pressure is 4,000 times the area, which is 0.3 meters by 0.4 meters. So when we multiply, we get 480 newtons. So for us to be able to get the upthrust on the block, we get the force difference at the top and at the bottom. And at the top we got 1,200 newtons minus the force experienced at the top, which is 480 newtons. And this gives us 720 newtons, which is the same as the answer that we got in alternative 1. Why are we subtracting? The force exerted at the top surface of P is downward, and the force exerted on the bottom surface Q is upward. So we get the resultant force, which is the difference between the two forces, which is equal to 720.